Hi everyone, today's class is about customized functions. The contents of today include multitasking. Multitasking means that while there is a rapid program running in the foreground for controlling the robot's logic operations and motion, there are also rapid programs in the background running in parallel with the foreground. A multitasking program can have up to 20 parallel rapid programs in the background with no industrial robot motion instructions. The multitasking program can be used for uninterrupted communication processing between the robot and the PC, or as a simple PLC for logic operations. The multitasking in the background program starts running continuously at the same time as the system is started, independent of the control state of the industrial robot. The steps for multitasking creation are as follows. Step 1. Go to Control Panel Configuration and select Task in Controller. Step 2. Click Add. Step 3. Set the task value to T-back and select Normal. Rename the main entry to main back to distinguish it from the main foreground program. Step 4. Reboot the system to make the settings take effect. After rebooting, click on the shortcut menu in the lower right corner and then click on Multitasking to cancel the TROB1 foreground task. Step 5. Go to the program editor and add the program module and the main routine. Add some instructions to the program. Step 6. Power up the motor, run the program, and observe the change in I/O. Also in Step 6, on the task editor, set the type to semi-static to run continuously in the background. Step 7. In Task of Control Panel Configuration, Controller, change the task to normal. Step 8. Create two num data ABB1 with the same name in two tasks that store variables in the program. Step 9. Change the task to run semi-static in the background. Step 10. Write an assignment statement in the foreground program to change the value of ABB1. Step 11. Execute the command and observe the value of the program data on the program data. Error handle. During the execution of the rapid program, some simple errors are self-handled in order to improve operational reliability and reduce human intervention. In addition to the systematic error handling, you can customize the corresponding handling as needed. It is better not to use motion commands for error handling. Common error handles are as follows. Here are steps for handling errors. Step 1. Go to the program editor. Create the routine RError handle and check the error handler options. Step 2. Add the waitDI instruction. Double-click on waitDI. Select the max time optional variable and set the value to 3. Step 3. Add TP-write command to add relevant information. Step 4. Edit the error handling at the processing instruction on the error. And next, add an if instruction with the following condition. ERRNO equal ERR wait max time. Step 5. The result of running the program is shown in the figure. Setting of TCP trajectory to limit the acceleration and deceleration speed. When an industrial robot moves high-temperature liquid metal for pouring, it needs to limit the speed of acceleration and deceleration of the motion trajectory to prevent the liquid metal from overflowing. The relevant instruction program is as follows. Use of World Zone. World Zone is used to control the robot to stop or output a signal. When it enters a specified area, this function can be used to set protection zones. When two industrial robots are moving together, it can also be used to set zones for opening and closing modes in die casting machines. When an industrial robot enters a designated zone, it allows the robot to output a signal to a peripheral device. The word zone includes a rectangle, a cylinder, or a joint shape. It can define the zone for monitoring based on 2 points of a rectangular prism. The world zone operating steps are as follows. Step 1. To use world zone, you must add the option 6081 world zone in ABB System Information, System Properties, Control Module. Options. Check if there is an option for 6081 world zone. Step 2. Select the tool you want to monitor in the manual operation. Step 3. Prepare the program corresponding to event routine. Set the two rectangular diagonal points, pose 1 and pose 2, and set the corresponding coordinate values with commands as shown in the figure to world zone and I/O signals. Step 4. Set event routine associated with power on to automatically turn on the world zone when the monitor is powered on. Limited single-axis range of motion. In the working process of industrial robots, the range of motion of a single axis needs to be set due to the working environment or the need for control. The data to be set is radian data, and the individual range of motion is limited by setting the upper and lower limit values for a single axis. When the single axis is limited, the operating range of the industrial robot becomes smaller. To limit the range of motion of a single axis, operate as follows. Step 1. In the control panel, configuration, click themes, and select motion. Step 2. Double-click arm. Step 3. Select the axis you want and choose that axis. Step 4. Set the upper and lower limits, upper joint bound of the single axis by modifying the values of upper joint bound and lower bound in radians, leaving a certain margin between the actual value. Click OK and the system will take effect after reboot. Step 5. Enter the manual operation mode, and the program will report the error when the axis movement is out of the set range, using I/O signals to operate routine programs. During the operation of the industrial robot, the operator will call up the rapid to be executed by the robot directly through the HMI. The HMI sends the program number to the PLC, and the PLC sends signals to the corresponding rapid on the group input of the industrial robot. The procedures are as follows. Step 1. Setting group input GI1. Step 2. Write several test programs such as PROC1, PROC2, and rchoose PROC to determine which corresponding program to call. Step 3. With the call by var instruction, PROC is a fixed value, and depending on the number that follows, you can choose to call PROC1, PROC2, or another program. Okay, that's the end of the class. Thanks for watching.